Hi everyone, I am Professor Amit Ved from Marwadi Education Foundation's Group of Institute Rajkot. Today I am going to discuss about the subject which is electromagnetic field theory, which is being taught in 4th semester, electrical engineering. The chapter which I want to take is vector analysis, chapter number 1, and the topic which I am going to discuss today is cylindrical coordinate systems. Now here in cylindrical coordinate system we know that it has got 3 coordinates, rho, phi and z. So if I compare it with our previous coordinate system, which was Cartesian coordinate system. So Cartesian coordinate system had coordinates which were given as x, y and z. But instead of that, now we are having another coordinate system, rho, phi and z. The reason why we want to take this kind of coordinate system is because many a times we will be dealing with cylindrical shaped materials, like we would be having capacitors, we would be having cables. So if I want to do any analysis with respect to these components, it is better I put it in the cylindrical coordinate system. So let us see that first of all where rho will be measured. So rho is always measured from positive z-axis towards the point of interest. So whatever is this radius I am getting, this radius is called as a rho. And the unit vector of arrow, it is also in the same direction as I can measure the rho. Now the second vector, second coordinate, if I go with, so I will have to take a projection of this vector rho on the xy axis. So when I take this projection of rho onto the xy axis, I am getting this point here, this line. So this line is along xy axis. Now this projection of rho makes an angle with positive x-axis, and this angle is taken as a phi. So this is my second coordinate. And for the third coordinate, I have to see that what is the height of this cylinder, and whatever is the height of cylinder, that will be taken as my third vector, third coordinate, that is z. So unit vector for arrow, it is in the same direction of z rho. Unit direction of unit vector of a phi, it is in the direction of the phi being measured from positive x-axis. A phi is always taken on xy plane. It is very important to note, and az is along z-axis. So now if I look at the range, so if we know that for Cartesian coordinate system, x, y and z, they are always taken from minus infinite to plus infinite. But here for cylindrical coordinate system, things would be little different. So we will take rho from 0 to infinite. We cannot take it as a negative because rho is a radius and it being a distance cannot be negative. The phi, it is an angle, and the range of this angle will be 0 to 2 pi. And z, we can take it same as what we used to have in Cartesian coordinate system. So we will take it from minus infinite to plus infinite. So now we will see that how we can do the conversion of one coordinate system to another one. So here first of all, this is the same direction of rho which was there earlier. So this is my rho, and this is the projection of rho on xy plane. And this projection makes an angle phi with respect to this xy. And the height of this point is z. So actually this point is having the coordinates, let us say that they are given as rho, phi and z. So now I want to convert rho, phi, z into x, y, z. So x, how can I find? So I will take this projection of xy on projection of rho on xy plane. So that is having the same length rho, and the angle between this projection and the x-axis is phi. So x component of this rho vector would be taken as rho cos phi. So I will take x is equal to rho cos phi. Similarly, the y projection of this rho onto the y-axis will be taken as y is equal to rho sin phi, and z will remain same. So I am having z is equal to z. So I will be able to very easily convert x. Will be able to easily convert cylindrical to Cartesian coordinate system. Now if I want to go reverse, so I will have to take these 3 equations into the consideration. So first of all, I will find out, I will take the square on both sides. So I will get x square plus y square is equal to rho square cos square phi plus rho square sin square phi. However, cos square phi plus sin square phi will be 1. And so I will get x square plus y square is equal to rho square, and that can be taken as rho is equal to root of x square plus y square. Similarly, if I divide 2 by 1, I will be able to get tan phi is equal to y by x, and so phi will be taken as tan inverse y by x, and z will remain the same. Now we will find out that what are the lengths available. So here you can see that we have taken one incremental volume, and for this incremental volume, if I will look at this height, so this height is along z axis and the length it is given as dz. So I can say that one of the length is dz. Another length what I am getting here, it is along the rho axis, and I will say that it is d rho. Now d rho and dz both are length, and I can easily consider them as a length. But when I take it on the third case, d phi, now understand d phi doesn't give me length, but d phi gives me an angle what I have here. So if I want to find out the length of this arc, then I have to take it as a radius into the angle. So rho is the radius and d phi is the angle. So rho into d phi will be the third length. Now I can multiply any of these two lengths together to make surface. So one of the surface is d rho dz, and the surface I am getting is this rho d rho d phi, and the third surface which I am getting is rho d phi dz. Now similarly I can have one volume, and that is multiplication of all this. So it is given as rho d phi and dz. Now another thing what we want to do over here is I want to find out the dot product in between one unit vector of cylindrical coordinate system and unit vector of Cartesian coordinate system. So ultimately what I want to find out, let us say I want to find out the dot product of Ax with arrow a phi and az. So let us see that how this can be evaluated. So let us take here the direction of Ax. It is unit vector Ax is in the direction of x. The direction of Ay, it is in the direction of y axis, and unit vector Az is in the direction of z axis. Now similarly, if I want to give the direction of arrow, so it is always taken from the origin towards the point of interest. So I am taking that arrow is taken from the origin towards the point of interest, and as you can see that arrow ultimately it is either parallel to xy plane or it is in the xy plane. So it is better we consider that arrow is in xy plane. Now another one I have a phi. A phi we always measure from x axis, so there is no point to consider it elsewhere. So we will consider a phi also, that it is available at xy plane. It is available on xy plane. Now it is very simple that we are having orthogonal projection, orthogonal coordinate system. So Ax, Ay and Az, they are 90 degrees. So similarly arrow, a phi and Az should be 90 degrees. So for the consideration you can understand that Ax, Ay, arrow and a phi, all these are on same plane, while Az is perpendicular to that plane. And if you look at the angle, so angle between Ax and arrow is phi, as we already taken. Now angle between Ax and Ay, it is 90 degrees. So naturally angle between Ay and arrow will be 90 minus phi. Now a phi and arrow, again angle is 90, so it means that this angle will be phi. So now let us go ahead. Now let us see that what will be, how we would be able to construct this table. So this is my arrow vector, it is on the xy plane. This is Ax vector, Ay vector, all these three vectors they are along the xy plane. And the angle between Ax and arrow is phi. So projection of arrow on the x-axis will be equal to cos phi, and projection of arrow onto the y-axis will be sin phi, and projection of arrow on Az, because angle between them is 90, so cosine of 90 will be 0. So I will get Az dot arrow is a 0. Now let us see that what happens with a phi. So again a phi is put on the xy plane, but a phi is at 90 plus phi angle with respect to Ax. So when I want to find out Ax dot a phi, the angle becomes 90 plus phi, and cosine of 90 plus phi is going to be minus sin phi. Similarly, if I want to find out Ay dot a phi, so angle between them is just phi, so I will take it as a cos phi. And for a phi and Az, so angle is 90 degrees as mentioned here, so cos 90 will be 0. Now let us see the third coordinate, which is Az. So now when I look at Az, understand right now that this Az what I want to take it is for cylindrical coordinate system. Of course it is there in the Cartesian coordinate system also. So Az dot Ax, angle is 90, cos 90 is 0. So I am getting here it as a 0. Az dot Ay, again cos 90 is 0, so I am getting this as a 0. And then Az dot Az, so they are in line only, and angle between them is 0 and cos 0 is 1. So I am getting Az dot Az as 1. So this is how we will be able to evaluate the dot product, and this is all about the cylindrical coordinate system. And the next presentation we will have will be on spherical coordinate system. Till then, thank you, goodbye.